Welcome back everyone to my Teacherla. Today we are going to look at a new topic on quadratic functions. So we will be looking at 6 different questions, topical exam questions that will give you about 31 marks. And the recommended time is about 40 minutes, but I made a tiny error here. But the original file that you will download from my link in the description will reflect the right value. Now, before we move on, thank you everyone for actually supporting my channel. So I would be really happy if you are able to subscribe the channel and share the link with your friends who are probably struggling with additional mathematics in school. All right, so let's start. So today's topic is, as I mentioned, quadratic functions. The first question, let me zoom in a little bit. All right, so it's a bit clear now. Okay, find the set of values of k for which the line y equals to 2x plus k cuts the curve. Okay, so given a function here at 2 distinct points. Automatically, when you see the word 2 distinct points, you should start thinking about the discriminant b squared minus 4ac, which should be more than 0. Alright, so this discriminant will tell you that there are 2 distinct points that this function is intersecting. So to visualize that, let me just show you how it may look like. Alright, so this is your quadratic curve and this is your linear line here that could intersect at 2 distinct points. Okay, now we have other variations, of course, which can be applied for different questions, which would be things like this. So this would be a tangent or intersection at one point, so commonly known as a tangent. So for this, we always say equals to 0. So b squared minus 4ac equals to 0. And then you have another situation where you have no intersection at all. So when you have no intersection, your discriminant will be less than 0. Okay, so these are the 3 different variations. Okay, so we will stick with more than 0 for this particular question because that's what we're looking at. So step 1 is to look at the 2 equations and you should equate them together. Remember that anytime there is an intersection of 2 different lines or curve or functions, what you're essentially doing is equating the 2 equations together. So that's exactly what I'm going to do. X squared plus kx plus 5 equals to 2x plus k. All right, so expand, make all the x on the left hand side. Okay, I mean pretty much everything, you just put it on the left hand side. Kx minus 2x plus 5 minus k equals to 0. Notice that I grouped up all the x together and all the constant values together. So 5 minus k is a constant. Now the next step that we need to do is to make sure that we factorize this so that's easier for us to imagine. Okay, so plus k minus 2. So it's easy for me to now look at the coefficient of x. Plus 5 minus k. Yeah, just put it in brackets to make sure that I tick the entire thing. Right. I'm just going to do baby steps for the first question to make sure that every one of you are able to follow. So from here, what's going to happen is that I'm going to try and apply the discriminant. Okay, so a is equals to 1. So that's the coefficient of x squared. Whereas b equals to k minus 2, which is the coefficient of x. And c is the leftover, which is the constant 5 minus k. Right, so let's get down to business. What we do is now to substitute everything into this particular inequality. All right, so I'm going to end up with k minus 2 squared minus 4, 5 minus k more than 0. So next step, expand this, k squared minus 4k plus 4 minus 20 plus 4k. Be very careful with your negatives and positives. You might end up making a mistake. Sometimes even I make that mistake, quite often actually. Alright, so k squared minus 16 more than 0. This is what I'm getting at the very end. Now notice that this is a square, it's a quadratic. So I'm going to try and solve for k first by pushing the 16 to the other side. And I'm going to end up with 2 values. But before I get the values, I just want to let you know that this is called a quadratic inequality. Alright, so there's a special reason why I'm specifying this. Okay, if you're familiar with it, then that's fine. Okay, so from here I can get 2 different values, k equals to plus minus 4. Alright, because we square root it and then we get plus and minus 4. But remember that this is not your final answer. If you go back to your original question, it kind of gives you a hint that k should be a set of values, right? So this is not really a set of values. These are just 2 different values, right? A set of values usually refers to a range. So how do we get that range? That's where the quadratic inequality comes into place. Now in quadratic inequality, we always think of it in terms of a graph. So let's say, for example, we have 2 different answers here. So I'm going to draw a smiley graph because k squared is a positive graph. I'm going to do 2 intersections. So the reason why I have 2 intersections is because I have 2 different answers. So one side I put a negative 4 and the other side I'm going to put a 4. Please always use this graph in order for you to do quadratic inequalities. If not, you're not going to get the best answer at the very end. Alright, so the next step, if this particular inequality says more than, you are to shade the top or the positive side of the graph. So which would be this and this. You must make sure that the shaded area is below the graph. So let's say, for example, I extend the graph here. It should be under the graph, not this empty region here. Okay, right. So once you have done that, okay, then you look at the inequality. How do we then write it? So the shaded region is where k is. So k is here, k is here. So on this side, from here to here, this is k less than negative 4. Whereas from here to here, k is more than 4. So you have 2 different range of values for k. Alright, so these 2 are your answers. Now try not to combine these 2 inequalities together. Then that's not going to be right. Because in this particular graph, we can see that the shaded region are not continuous. Okay, what I mean by continuous is that if let's say I shade here, this range is continuous from here to here. These 2 ranges are separated by this non-discontinuous region. Alright, so that's about it. So your final answer should be this. Let's move on to the next question. I hope I'm not going too fast. If I'm going too fast, you can just slow down, okay, on the channel itself and try to catch up. Okay, right. So question number 2, sketching the graph. Sketch the graph of y equals to modulus of x squared minus x minus 6, showing the coordinates of the points where the curve meets the coordinate axis. It's quite important to always look at what they really want on the graph. So they want you to show the coordinates of the points where the curve is actually meeting the axis. In simple terms, what they basically want is the intersections on the x-axis and on the y-axis. So as long as you show that, you probably get the full marks. And of course, you must have the right shape of the graph. So let me break this down into steps first. So the steps that you need to take in order for you to sketch most of the graphs is this. So step number 1 is to get your x-intersection. I mean, you can do this at following whichever steps that you like first. So x-intersection means y equals to 0. And the next one would be y-intersection. I mean, some of you might call it intercept. That's fine as well. I mean, yeah, that's probably the better word to use. Okay, I don't know why I ended up with the intersection, but never mind. All right, so, okay, I'll just quickly correct it. Okay, it's intercept. I mean, it's not wrong, but yeah. All right, okay, let's not waste time there. So step number 3 is line of symmetry. So especially if you're drawing a quadratic graph, this would prove to be very useful. So line of symmetry, or you can also get the maximum minimum point, whichever feels more useful to you. Now, if the question asks you to show the max and minimum point, please make sure that you find this step. All right? Okay. So later I'll show you why this third step is quite important, so that you get the right shape of the graph. Okay, let's start by looking at all of the values. So I'm going to start with at y equals to 0. Okay, what's the value? So I'm going to break this up into 2 parts. X squared minus x minus 6 equals to 0. And x squared. Okay, oops, my bad. I don't have to break it up. Ignore. Okay, so because that's the other part is the x equals to 0, which I'll talk later. All right, so just factorize this. You will end up with x plus 2 and x minus 3 equals to 0. So now you're getting x equals to negative 2 and x equals to 3. So you have 2 values here. If I were to convert this into a coordinate form, then I'm going to get negative 2, 0. So my y is 0 here, right? So for this one, 3 and 0. So you have 2 extra coordinates. So the reason why I'm writing it in full coordinates is because I'm just being very careful that the question says showing the coordinates, right? Okay. So you should show it on the graph, of course, but yeah, I'm just being careful. It's always good to be careful. Okay, so that's one. And the other part is trying to find at x equals to 0. Okay, so at x equals to 0, you put them in the modulus, substitute x equals to 0 here, gonna get 0, minus 0, minus 6. Okay, this is 0 squared, but yeah. Okay, simplify this, you will end up with negative 6. And because there is a modulus, this becomes a positive value. Now, the coordinate for this is 0 and 6. Okay, the last step is trying to find the line of symmetry. So the line of symmetry. Pardon my writing. Okay, so in order for us to find the line of symmetry, it's quite useful if I start by putting up the values on the grid of a graph. And then I'll explain to you how it works. Okay, so this is x, this is y. Right, so we had the intersection negative 2 here, right? So I'll just put a negative 2 here first. Then we had a 3, so 3 is probably somewhere here. Okay, now we're good to find the line of symmetry. So a line of symmetry basically means something, not something, but it's supposed to be a vertical line in between the x-intercepts. So here and here. So how do we find what's the middle line? So in order to do that, you do this. You take negative 2 plus 3, right? So that will give you the distance from here to here, and you divide it by 2. So in our case, we are going to end up with 0.5. Therefore, the middle line, or the line of symmetry that cuts them into half, is somewhere here. Okay, it's not extremely accurate, but yeah. So this line of symmetry will help me to give the shape of the graph better. Okay, to imagine the graph shape better. Okay, so now the next one is this one. I haven't put this up in the graph yet, so it's 0, 6. So I'm just going to put a 6 here. All right. Now, in reality, if this is not a modulus function, your graph should look something like this, right? But because this is a modulus graph, therefore it will be reflected to the top. So when I draw this graph, it kind of should look something like this. I'm really bad at drawing, so please bear with me. Okay, something like this, go up, and notice what I'm doing here. It should curve and tip the maximum point on the line of symmetry. Okay, so the tip or the maximum point, the vertex, must be on the line of symmetry. So please, that's one of the reasons why we found out the line of symmetry, because we want that shape there. If not, common mistake is to tip and max at the point of intersection at y. That's wrong. So you'll get up a very weird little shape. Okay, and this should look like a nice curve like that, and like that. So I'm just taking it from here, basically. All right. So that's basically how it should look like. So we are done. We showed all the intersections and we showed the line of symmetry. So we're good. So that's all the marks that you're going to get. Okay, double check. Yes, we're done. Okay. Along the way, if I do make any mistakes or errors that I just went through with it, please just comment on the YouTube channel, so that, I mean, on the YouTube video down there, so that I know what's wrong. Okay, and I'll try my best to make the correction as soon as possible. Okay, so the next part is solving the equation. So let's say we are given a quadratic modulus and equate this to 6. How do we solve this? Okay, let me just rewrite this. Okay, whenever you have a modulus, it just means that you have all positive values, correct? It's basically, you can imagine this as a root. Whenever you do a square root, you always have a positive and a negative answer. The reason is because if I square it, the negative, I'm going to get a positive. I square this, oops, sorry, 4. I'm also going to get a 4, right? So very similarly, a modulus function, okay, if I have a negative 2, I'll get a 2. If I have a positive 2, I'm also going to get a 2, right? So there are 2 ways to break it down. Okay, so I'm just going to make sure that I break it down. Careless mistake is not breaking down into the 2 positives and negatives. So step 1, do that. Okay, normally I wouldn't explain in details. I would expect you to know, but just to make sure everyone is able to understand the concept behind it, we'll just do the baby steps. Okay, so this is what we have. So one side is the positive side and the other side is the negative side. Okay, so you have to solve for both. Notice that I've removed the modulus by now. Okay, so simplify this. X minus 12 equals to 0. Factorize x plus 3, and then x minus 4 equals to 0. Get your x values, which is negative 3 and 4. So you have a set of values here, and then you will have another 2 values here. Okay, x squared minus x equals to 0. Factorize this, x minus 1 equals to 0. So when you solve this quadratic, you have x equals to 0, that's 1, and then x equals to 1. That's it. Okay, so notice that if you forgot one of the, either the negative or the positive 6, you're gonna miss out 2 values, so you will not get the full mark. Okay, let's move on. By the way, I think I need rest. I'm doing this at night, and I need some sleep so that I can catch the Belgium versus Portugal game at 3 a.m. Yes, I'm from Malaysia, so the game is at 3 a.m., so it sucks big time. Alright, I'm not sure if you're a Portugal fan or a Belgium fan, but I think Belgium might win this with a 2-1. I don't know. If my prediction is wrong, please just, yeah, don't complain. Okay, let's see. The equation of a curve is y equals to 2x squared minus 20x plus 37. Alright, so express y in the form of this, where a, b, c are integers, and write down the coordinates of the, yeah. Alright, so let's do the first one first. Now, this is basically a form of completing the square. Right, so I hope you remember or you recall what is completing the square, but it's okay if you don't. I will go through step by step. So we need to complete the square from here so that we can get this form. So the first thing that we need to do is step 1, to make sure the coefficient is the coefficient of x squared is always 1. Now right now it's at 2. So what I'm going to do is that I'm going to divide everything by 2. Okay, there are multiple methods of completing the square, but this is the method that I quite like. And I realized that there's less errors when my students actually do this method. So I'm just going to divide everything. So that's my step number 1. Okay. Equate it to 0. I mean, you don't necessarily need to equate this to 0 because it's just an expression. So yeah, I'm just going to do that. All right, so then how do I simplify this? So the way that I want to do is that the next step that I need to do is always to take into consideration the coefficient of x. So according to the completing the square method, what we need to do is to find the half times coefficient of x. Okay, so half times coefficient of x. Make sure you, if it's a negative, you take the negative together. And then you square it. After you square it, get the value, -5 squared. Notice that I'm not going to expand this yet. I'm just going to keep this form. Okay, so that it's easier for me to do the substitution later. You will see how and why. So the next step is, after I've found the coefficient, I'm going to take this and put it here. What I'm going to do is that I'm going to add and minus this on 2 different sides. Okay, so x squared minus 10x. Notice I'm going to use a different color so that you notice what's different. So I'm going to add it here. Okay, and continue with the regular value. And after the constant, I'm going to minus it. Okay, so when we actually add and minus, we are not changing the entire value of the equation. What we are doing essentially is just changing the way it is being represented. Okay, so my next step would be removing the coefficient. So the coefficient is being addressed by doing this method. So that's completing the square. All right, so how do you address it? You take x minus 5 and square it. Okay, so I took the x from here, minus the 5 and square it. So if I were to expand this, I'm going to get this back. Okay, so remove the -10x completely. You don't have to care about it anymore. Now, then from here to here, simplify it, and then you will get a value. In this case, I get a 6.5. All right, and make sure you keep this in the bracket, in the square bracket. So the 2 is outside. So we need to deal with the 2 in a bit. Okay, so we're done the completing the square. So now we're dealing with the 2. Open up the square bracket. Okay, you multiply this in, and this 2 must multiply this. So you get -13. Common mistake is to forget the multiplication of 2 here. which is the reason why I'm using a square bracket, to make sure I remember to do the multiplication of the constant. Now, we are there. Notice that this form is now the same as this. So we can make use of, we can get all the values of A, B, and C. So if you like, the question asks you to express it. So I've expressed it already. But if you like, you can also write down the values. A equals to 2, B equals to -5, and C equals to -13. Okay, now let's move on to the next part of the question, part 2. So they want you to write down the coordinates of the stationary point on the curve. It's just 1 mark. So whenever it's 1 mark, it's something that should be quite obvious. So the best thing about completing the square form, this particular form, is that it gives you a lot of information. One of the information that it actually gives is the stationary point. Now, it's quite funny why they call it stationary point, because, okay, I'll just show you what it means. So let's say if you have a graph like this, okay, so let's say this is a quadratic graph. So this is basically your stationary point. So there are many names for stationary point. So one is stationary, the other one is a turning point. I mean, you can understand why is it called turning point, because it turns from this way to this way. Okay, and the other one is, this is also either a maximum or minimum point. I mean, that's quite easy to understand why. Now, the word stationary point actually comes in differentiation when you actually try to find out the instantaneous value at this point. It's always a 0. So in other words, dy dx equals to 0. Okay, right? Your gradient is 0. That's basically it. But never mind. This is not that chapter now. Okay, so that's just extra information. But so how do we get the stationary point? By using this. So it's quite nice that this magically gives you the answer. So let me try and choose a different color. Okay, never mind. I'll just use black. So the stationary point value is 5, -13. How did we obtain this? We obtained it from here. So remove the negative, put a 5 here, and take the -13, put it here. Finish. That's your coordinate. So this -13 is basically your minimum point, whereas this this 5 here is your x value, at which the minimum point occurs. So that's how you get the values. Alright, so that's basically it. Okay, I hope I'm not mumbling too much. If I'm mumbling, just forward it. Okay, let's go to the next question. We have, I think, a couple more to go. I can't remember the number of questions that I put. I think I put 6 questions probably. Okay, so 2 more questions to go. I know 3. Right, question number 4. A function is defined by this, where p is a constant. The function can also be written in this form. So notice this is the full form, okay, the standard form, and this is the completed the square form. So you're required to find the values of p and q. So what do we do? Step 1. I know that this and this are the same. Okay, so the first thing that I'm going to do, the simplest method of all, is to just expand this. So I'm going to take this, okay, and I'm going to expand it. So when I expand this, baby steps again, I'm going to show you baby steps. X minus 4 plus q. Okay, I'm going to expand the insides. I get x squared minus 8x plus 16. And then remember the q. Expand this further, and I'm going to get 5x squared minus 40x plus 18 plus q. Now we're almost there. Now this is supposed to be similar to this. Therefore, I'm going to make a comparison with this. So 5x squared plus px plus 72. Okay, so I'm just going to make a comparison. So I'm just going to use this symbol for comparison. If I'm not mistaken, this should be the symbol for comparison. But anyway, so let's try. So yeah, it's quite easy to see that p must be equals to negative 40 because both are the coefficient of x. Therefore, p equals to negative 40. Done and dusted. What about the next part? So the balance constant we have is 80 plus q, and the balance constant here is just 72. Therefore, I'm going to equate them together to say AT plus q must be equals to 72. Then I get the value of q, which is equivalent to negative 8. So that's basically how I find my p and q. That's 3 marks. We're done. All right. So while I'm at it, we have 2 more questions. Find the range of the function g. So I have some space here. So let me just squeeze it in. All right. So in order to find the range of function g, we must first write down the full function of g. Okay, I'm going to use the second format, and there's a reason for it. Okay, I'll show in a bit. So when I write the second format, I'm going to get 5x minus 4 squared. Q was negative 8. So this is my gx. All right, so this is my gx. Sorry about that, it looks kind of weird, but never mind. Now I want to find the range of this function. So remember that range are values of y. So we need to find out what's the minimum value of y and what's the maximum value of y. Remember that this is a quadratic that will look something like this. So this is your minimum value. So in as I mentioned earlier, when you're in this format, this value here is your minimum value. And in a quadratic function, you don't actually have a maximum unless it is defined in the question that says domain blah blah blah. But in this case, there is none. Therefore, it just goes to infinity. Okay, in this case, it's positive infinity. Right, so since your minimum is negative 8, so your graph should look something like this. Your value for the range should always be more than or equals to negative 8. So you can start with negative 8, but you can go everything and above negative 8. But it can never be below negative 8, right? So that's it. That's your 1 mark. Okay, and finally, sketch the graph of the function on the axis provided. I hope I did provide the axis. Oh, yeah, yay, there it is. Okay, so I'm just rewriting the function again for ease. Okay, gx is equals to 5x minus 4 squared minus 8. Okay, so again, some steps that we need is I need to find the intercept. So I want to find the y-intercept. So at x equals to 0 or g0, I'm going to get 72. Okay, so when I substitute 0 into this, I'm going to get 72. So that's this point. Let me label that on the diagram. This is 72. All right. Now, the other thing that I'm getting is that negative 4, okay, x equals to 4 is line of symmetry. Okay, my s is, this is, okay, never mind, forget about the spelling. So let's just say this is the line. So again, this completing the square equation will always give me the location at which the line of symmetry is. So this is also the location at which your maximum or minimum point will be at. Right, so your minimum point is at negative 8. So let me accommodate for that and put a negative 8. I mean, practically speaking, it shouldn't be that low. It should be somewhere here. but never mind. I can only show so much. Sketching the graph, so it's not too bad. Right, so I can already start drawing my graph. I don't need to find my x-intercept because the question didn't ask us to do so. Okay, so you don't want to spend too much time on that. So I'm just going to draw this. So it's just going to go like this. Oh no, oh no. And bend right here. Oops. It's not so easy to draw or sketch on my writing pad. Okay, so that's it. That's your answer. We are done with question number 4. We still have 2 more questions to go. And I think I need some water, but never mind. I'll just finish this since I'm recording it. Okay, question number 5. But as a break, please, if you've enjoyed the lesson up until now, please make sure, please help me to subscribe for the channel and do share it with your peers, friends and family who are taking up GCE or IGCSE. Okay. Find the values of m for which the line y equals to mx minus 5 is a tangent to the curve. So I kind of hinted this in the very first question that we did. So when you have a tangent to the curve, you have a discriminant b squared minus 4ac must be equals to 0. So it just touches like this. The tangent just touches at one point, so you only have one root. Okay, so in other words, this is one root. Okay, but sometimes they might also say 2 equal real roots. Okay, just so that you know all the different reasons why. If let's say you end up with an equation like this, this is a quadratic equation, but there are 2 equal roots. Or you can just say it's just one root, right? So that's the reason why. But anyway, that's not the part of the question, so it's just separate. Don't get confused. Just extra information on the topic. Alright, so going back to the question. So after you kind of determine this, what we do is we need to substitute, not to substitute, but equate them together. So the intersection basically, x squared plus 3x plus 4 equals to mx minus 5. Okay, rearrange this as usual. I'm going to speed up a little bit. Plus 3 minus mx plus 9 equals to 0. Do my b squared minus 4ac. So a is 1, b equals to 3 minus m, c equals to 9. Okay, you can ignore this. If you're very good, you don't have to specify all the values, but it's good just to make sure you don't make a mistake. Substituting for baby steps for you. Okay, especially if you're just trying to learn the topic, it might be difficult to follow. Okay, m squared minus 6m expand 27 equals to 0. Notice that here you get equals, so there's no inequality, so you can just straight away get the answer. Okay, m minus 9 equals to 0. So m is negative 3, one answer, and 9. Alright, so negative 3 and 9. That's it. Question number 5 is quite straightforward and easy. So that's 5 marks in less than, what, 3 minutes? I think, with some explanations. Alright, the final question of the day before I get some water and some sleep. Okay, solve the inequality. Alright, so let's look at it. So I'm just putting up the inequality in this chapter as well because it's still quadratic. So expand this and I'm gonna get negative 4x squared plus 16x more than 7. It's quite interesting. The more than and my 7 kind of looks the same. I hope I don't get confused. Negative 4x squared plus 16x minus 7 more than 0. I did almost get confused. So I just pushed the 7 to the left hand side so that I can get a full quadratic form. Now the next step is not necessary, but it's useful. In some cases you might have to do this, so I'm just going to show it either way. Now I want to change the entire equation to become more positive in the front, so the coefficient becomes positive. So in order to do that, I times by negative 1. So the entire thing was going to become multiplied by negative 1. Okay, when I do this, you must remember to switch, okay, the arrow. Okay, so if you don't forget, if you don't switch it, then your inequality is no longer valid, right? It's not necessary, again, as I mentioned, but I personally would like to view everything in the positive way. So yeah, I prefer to do that. And then I do the factorization. So then when I factorize, I'm going to get 2x minus 1, 2x minus 7. But again, you can still factorize this without doing this yet. Okay. All right, so I'm going to get x equals to 0.5 and 3.5. So this is where you have to look at inequalities. As I mentioned in the first question, whenever you have quadratic inequalities, you cannot give your answers like this. So refer to your graph, okay, sketch it. There are two intersections, so make sure you have two intersections. One is 0.5 on the left hand side and one is 3.5. So the inequality says less than, therefore I shade everything below the graph. Below the x-axis, not the graph. Okay, but it must be bounded with the x-axis. So that's basically the region that you're interested in. So x is lying in between there. So the final answer should be x more than 0.5. Okay, notice that it's always more than 0.5, but it's always less than 3.5. And that's it. That's it for quadratics, the quadratics chapter. This ended up being a very long session. It's about 42 minutes on my screen. Okay, hope you enjoyed the lesson. If you have any questions, please just drop by on the comment section and don't forget to subscribe. Thank you very much.